Welcome to secondary steel making course lecture 21. Let me emphasize on few more steel grades such as interstitial free steels. In a previous lecture I was talking about transformation induced plasticity, twin induced plasticity and dual phase steels, which are also the category of low carbon steels and having with dual phase and transformation induced plasticity, twin induced plasticity. One is phase transformation based, the other thing is two phase coexistence based steels, the other thing is twin based, there is no phase transformation, which are proven to be having the high strength and suitable for the automobile industry structural part of the steels. Now let me speak few more low carbon steels. Why it is being important, the secondary treatment of the steels, which is playing an important role because of if you are not using the steels, you need to go for the polymers and composites, and the investment cost for the construction of the car body and automobile industry applications goes high. For compromising this particular part, it is devised the secondary treatment for the steels. Why don't you change the steel properties and bring down the weight and increase the strength? It is being done with a lot of studies and scientific studies are existing, and finally it is being adapted with these variety of low carbon steels with modifying the second stage treatment with combination of thermomechanical treatment. One such steels types are discussed in the last lecture. Now let me emphasize on few more steels, that is interstitial free steel. The interstitial free steel, what are the interstitials in the steel? Mainly carbon and nitrogen, and we are talking about low carbon steel. The carbon is primary element, that is why we speak about the carbon. In the case of iron carbide diagram also, we divide the steels with respect to the weight percentage of carbon. Now let me give you the few important points about this interstitial free. It doesn't mean that there is no interstitials. There is interstitial element, but with very low. That is the first point says the low carbon steels are proven and becoming evident in all these applications of car body. The deep drawing properties or deep drawability properties are increased by decreasing the carbon content in steel, and that was the main point towards developing of interstitial free steel. These interstitial elements could not be only carbon, it could be the nitrogen also, and it should be reduced as much as possible for achieving this particular deep drawing property. This is important point to be noted. And the conventional or the old interstitial free steels contains 20 to 30 ppm of carbon and 30 to 40 ppm of nitrogen. In the modern days, even this percentage also further decreased and improving the deep drawing properties. And this particular interstitials can be captured by the small addition of titanium niobium, becomes, it could be the carbide, titanium carbide and titanium nitride, which becomes as a precipitate second phase particle after during the hot rolling process, so that there will not be grain growth. If grain growth is occurring, you will need to be compromise about the strength. Strength will be decreased. It should be optimum. That is being done by this addition of elements, and this particular interstitial free steels have the R bar is a parameter which gives an idea about deep drawability of steels. This IF steels have the R bar values in the range of 1.8 to 2.2, which are quoted in the many of the scientific articles and textbook. But this particular, since it is interstitial free steel, you can also call it as a pure steel, but it doesn't mean that it is iron. It is a steel with low percentage of carbon. This particular low percent pure steels have the problem of fine grain size, achieving the fine grain size after hot rolling while you are cooling. You cannot achieve those things. There should be at least some precipitate so that it hinders the further grain growth, it stabilizes, equilibrium grain size will be achieved so that the strength goes high. And the processing conditions of mainly for the interstitial free steels are the chemistry of the interstitial steels should be maintained low carbon and nitrogen, and it should be balanced with titanium, niobium, so that all the problems could be rectified and it becomes suitable application for the car body application. The grain size control can be done by the addition of titanium and niobium and allowing to form the precipitates such as titanium carbide and titanium nitride with niobium same. And the finishing, you can go for the further grain refinement, you can go for the annealing, choosing the temperature of very low below the A3 temperature as per the iron carbide diagram, and you can use the higher temperature also because the carbon content is lower. It could be only arsenic grains will exist, and if you add this particular carbide forming elements, the arsenic grains could be restricted so that the strength can be improved. And this is broad pictorial graph about the deep drawing properties, deep drawability, that is R bar values for all these particular steels. IF is interstitial free steels in the range of this thing 1.8 to 2.2, along with the interstitial free steels and high strengthened steels, high strength steels, and aluminium. By the addition of the aluminium, killed steels, low carbon steels range is this, and BH is bake hardened steel. The steels which are formed and pressed are maintained with the different around 170 degrees temperature. Paint, that particular painting and heating provides the further hardening, is nothing but bake hardening. Rephosphorylation, for increasing the corrosion resistance, the phosphorus amount is increased. There you will see this range of the properties. High strength low alloy steels, this is the range. Dual phase steels, the bottom one. Transformation induced plasticity, the top one. And similarly ultimate tensile strength values is also depicted here, and one can get the clear idea about that the R bar values are very high for interstitial free steels. That is why that particular grade of steel is become the prime importance and first steel for the application of car body, and entire car body cover made up of interstitial free steels. And the other grade of steels are high strength low alloy steels. The alloying addition of niobium and titanium with very low, that particular steels are high strength and low alloy steels. The second possibility when people are thinking about this particular problem, pure steels, problem with the pure steel and interstitial steels, how can you increase the strength further and further? The idea which is being introduced is precipitation hardening. If you add addition of These particular niobium and titanium addition of small amount also, it may form carbide or combination of carbonitrate and becomes as the precipitates. That particular precipitates intersect the grain boundaries and stops the further grain growth around the austenite grains of the steels during the hot rolling process. And the main mechanism is, during the hot rolling process, this particular niobium carbide or titanium carbide or nitrate becomes undissolved fine particles which restricts the grain growth of the austenite grains during the hot rolling process of these steels. During hot rolling process is chosen, making this particular sheet further and further thin and without any defects. And similarly it should have the high strength. And the last step of hot rolling process, making the further thin and thin, this particular precipitates are present in this particular steel. That is why there will not be any recrystallization. It will be flattened or equilibrium size of grain will be achieved because of this particular point. And when you go for the subsequent cooling process, the austenite, maybe other ferrite nucleus may be activated. That particular fine ferrite grain size, those are the fine size. Because of the fine grain size, the strength goes high. That is the important contribution. These particular key points one need to remember for any of the competitive exams and viva questions and exams. Now, thinking of going for the other type of steels, and these grades are, and another thing is bake hardening steels. That is the bake hardening steels. Let me speak about the bake hardening of steel. Initially, the sheet for the car bodies, it should be much soft. It means it should have the high ductility and highly deformable. That particular sheet supposed to be selected, and that particular sheet supposed to be sent for the hot rolling process, which is nothing but forming or pressing process into the desired sheet thickness. That particular, by this particular process, it becomes so strong as possible without any defects during the hot rolling process. But after this particular pressing, when you are assembling in the car bodies, that particular steel, after hot rolling process, it is white in the sheet of the steel. It should be painted, and while you paint also, you need to provide the firing temperature of this particular baking cycle, which is nothing but paint bake cycle with maintaining the temperature of 170 degrees Celsius temperature for an half an hour. This is nothing but aging process. This is where the baking is occurring. Because of this particular baking, the material, the austenite, some of the austenite, retained austenite is converting into the martensite. The surface of that particular sheet is becoming hardened during the subsequent application. And even for the environmental condition, nature also solve this kind of problems. Because of the temperature ups and downs, it adjusts itself. This particular treatment is useful for that particular condition. The main idea of bake hardening is increasing the surface hardening, is nothing but surface heat treatment. It is just like strain aging reaction or precipitate hardening reaction is provided. And the summary about these particular high strength steels with a low carbon content, if you see that particular elongation values with respect to the tensile strength, IF steels, low carbon steels, the tensile strength is this much, and other steels, trip steels, this is tensile strength and total elongation values, and this is martensite steels, and dual phase steel combination of carbon phosphorus steels with the manganese addition steels, alloy addition, ultra high strength steels, and high addition of high strength steels. These kind of steels are summarized here. How the elongation and tensile strength is varied. High strength greater than 700 megapascal and less than 270 megapascal. These are the variety grades of steels. And the other point about this thing is the weight reduction is further increased. That particular demand is still going on. The new family of high strength steels are being developing even today, and those particular new steels, as I emphasize as a part of this particular topic, is dual phase steel, transformation induced plasticity steel, and ferrite bayonet, that is another dual phase steel, and complex phase steel, DP steel and complex phase steel, and twin induced plasticity steels. These are the variety of steels are emphasized today. Now let me speak about the other concluding point, that is, give your opinion with true or false. The addition of small amount of carbide forming elements such as niobium and titanium, which act as undissolved fine particles during art rolling process, will restrict the grain growth. Is it true or not? Please give your opinion.